So there it is. Trigonometry is kind of like a welcome back. Okay, so far we covered the following. Okay, so we talked about the Pythagorean theorem. Right, and we talked about, I call this missing leg, and the other option, the other situation is you're missing the hypotenuse. Right, so if you're missing a leg, then to find that leg, you would just take the square root of hypotenuse squared minus the other leg squared that you know. Okay, if you're missing the hypotenuse, right, let's call hypotenuse what it is. Hypotenuse would be the square root of leg squared plus leg squared. Right, there are two, the other two sides are called legs. We square them and add them up, and then obviously always take the square root of it. So you square everything and you square root your final answer. Okay, and there you have that. So we started with the Pythagorean theorem, then we did multi-step Pythagorean questions, and they look like this, right? Like at first we started off with something like this, right? You had one of those, or I would have given you something like this, right? You have your 90 there, and then another one stacked on top like this. And keep in mind, they can have many different versions of this, but those were multi-step. You needed to, start with one triangle and then move over to the other side. And then we also did word problems. Right? And the biggest, right, it's a guy wire. Remember that? Like a guy wire keeps a post straight, and so the guy wire and the post and the ground make the triangle. Okay, so we covered word problems. We talked about base of the ladder, foot of the ladder is leaning against the wall, stuff like that. So we've done that. We also check if triangle is a right triangle. I don't know if you remember that, but you basically are checking if a squared plus b squared is in fact equal to c squared. If you plug in all the values and both sides aren't equal, then it's not a right triangle, right? So this is the left hand side has to equal the right hand side. That's what we call it. Left hand side of the equal sign has to equal the right hand side. If that's not the case, then you conclude that it isn't a right triangle. Can't be done. So this, what I've just talked about here, this is basically what I call like part one. Okay, that's all part one. That was all Pythagorean theorem. Okay, so there were no angles involved here. So when you have no angles, just two sides, you use Pythagoras to find the other side. Okay, that's how that works. So I'll leave it up there for a bit, and then we'll do part two, which I will already give you the topics that are to come that we're going to cover yet down the road, so that you already have like the complete overview of what to expect. Now, Does this cover every single scenario? It doesn't. It never does, right? You gotta go through your notes, what we've done to review, but this definitely is a good picture, right, to summarize. Okay, then so then we entered Sohcahtoa. Okay, so trig ratios, right? Also known as Sohcah, right? Sine, cosine, and tan. And they're the sides that go, every single one has two sides that is equated to it. Okay, Sohcahtoa. So trig ratios there. We used it. We use that. So let's go arrow down like that to solve for sides. Okay. We also used it to solve triangles. And what is that? Solving triangles just means you solve for all angles and all sides. Okay. And we did that. What are we going to do down the road? So we basically just did trig to solve for a side length and to solve triangles, right? We've done that, but we will still do more, right? So trig to solve angles. So we're going to do that. This is called the inverse. If this doesn't mean anything to you, don't worry. I'm going to go over it, okay, down the road. But we're going to use trig. We're going to use Sohcahtoa. And remember, Sohcahtoa is just an acronym that we came up with to basically tell you we're talking about sine, cosine, and tan, and that sine goes with opposite side divided by hypotenuse. Cosine goes. So you shouldn't have Sohcahtoa in your calculations ever. Like some students write down so of 40 degrees. It's like, no, it's sine of 40 degrees, right? So don't mix that up. It's not, it's just to help you remember. It does a couple of things. It helps you to basically eliminate two of them because you can only use one, right? So if you're left with the two sides that remain after you cancel the don't know, don't care side, you're left with just one of them. So let's say it's sine, right? That means that you're going to have to start with sine of angle is equal to opposite over hypotenuse, like in that order, okay? So what's coming next is we're going to use trig to solve for an angle, to find the actual angle, the opening, right? The measure of the opening between two sides. And we're going to use trig to solve word problems. And we're going to use trig to solve multiple triangles. Okay, so this one is coming up, right? This is coming up, and this we've solved already. So, but this whole thing here is part 2. Okay, so part 1 is Pythagorean Theorem, and part 2 is Sohcahtoa. How do you know when to use what? As soon as there's an angle mentioned, I would right away go over to Sohcahtoa. If there's no angle whatsoever, except for obviously there's always a 90-degree angle or else these don't work. Then you use the Pythagorean theorem, right? If there are only sides, Pythagorean theorem. There's side and angle, use Sohcahtoa, all right? And so We're going to continue now with, again, just the basics, because when I corrected it, I still found a lot of mistakes. Okay, I found too many mistakes. And so we're going to continue with our notes, and I hope you are writing this down. And here we go. I have a handout here for myself to follow, and then I can keep track of where we're at. Okay. So continue. Don't leave the meetings, okay? Because I can see that, right? Sometimes you need to do that to rejoin, right? And actually something is wrong on the internet or internet side or technology side that you need to refresh your connection. I get that, but you're only missing out then if you do that, right? Okay. So here we go. Write this down. Find the value of each trig ratio. And by the way, whenever we say trig, we actually mean trigonometric ratio. Okay, that's it's a full sentence. Okay, so let's see here. I'm gonna write it like this. X, Y, Z, 35, 28, 21. Somebody wrote something. Okay, yeah. 1 second, everybody. Okay, I'm sure that more than. Go ahead and copy that down. And so my goal is that you become quite comfortable. All right, thanks. Quite comfortable with trig, and that it almost becomes, second nature, that you can just do it no matter what grade you're in. Grade 11, it comes back. And it comes back, but it's shorter, and there are more word problems. So they're not technically, there's only 1 week devoted to it according to the curriculum. So that's not a lot of time. Okay, so there won't be a lot of time for whoever teaches you in grade 11 to review trig. Okay, so you're just gonna have to hit the ground running, basically. Okay, so copy this triangle. I'm going to ask you to write the trig ratio for tan of angle Z or Z there. And I'm also going to ask you to write sine of Z and cosine of angle Z. So you've got all three ratios. They're a little bit mixed up, but each one of them needs two numbers or letters. It depends on how the question is set up. In this case, there are numbers for every side. So all three have a number. And please do this for yourselves, right? Sohcahtoa, just write it down whenever it's trigs. Like, wait a minute, I need my Sohcahtoa. Or have your study sheet right there. That way you can check, right? So write those two numbers that you believe should be going here, write them down, and then check to see if you got it right, because I will be doing that with you. All right. So if you're watching this ever, right, you always press pause and try it, right? If you're actually doing this. So tan of angle z, and remember the angle, if it's in letter form, it's the reference angle. So that's basically where you position yourself. And every triangle has three sides, especially when dealing with Sohcahtoa. When we're doing Pythagorean theorem, it's legs and hypotenuse. That's it. But if you're using trig, sine, cosine, tan, this is your reference angle. You travel out. This is the opposite, hypotenuse, which never changes, and is the adjacent. Opposite and adjacent will change based on if you're here or here, right? They kind of flip-flop. But right now, Z it is for all of them. Okay, so tan of Z, you labeled your sides. You go and look up tan, it's calling for opposite and adjacent. So opposite is 21, adjacent is 28. That's what goes there. Sine of Z, sine is so, right? Opposite hypotenuse. So opposite is 21, hypotenuse is 35. Cosine is ka, right? Adjacent hypotenuse. Adjacent is 28. Hypotenuse is 35. Boom, you're done. Okay. Let's do another one. We have one of those. We're going to go A, B, and C. Cosine of C, tan of C, sine of C. So I'm mixing it up so it's not always Sohcahtoa, right? So now do the same thing with this triangle. Put the two numbers in that each trig ratio should have, right? So go for it. Take a few minutes, right? Ready? Cosine of C. Somebody said something here. Okay. All right, Montana. Get some loose leaf and write this down, okay? Cosine of C. Again, it's important, right? C is your reference, so that means that you're positioned here. Travel across, you call that opposite. Across the 90 is always the hypotenuse, and this is your adjacent. Okay? Cosine. Let's go up here, adjacent hypotenuse. So 48 is your adjacent, hypotenuse is 50. So that's what goes there. Tan is TOA, so it calls for opposite, which is 14 over adjacent, right? That's what A stands for, and that's 14 over 18. Sine of C is SO, so it's opposite over hypotenuse. And so that's what you put there. One more. And this one I'm going to put a little twist on it. DEF. And we're going to go 45, 27, and 36. And we don't have units in here, so that's fine. So I'm going to go cosine of F, sine of F, tan of F. Okay, you put the numbers there. And then I'm going to go cosine of d, sine of d, tan of d. So basically you're just asked to put the two numbers where they belong, right? That's all you have to do here. So try that for all 6 there, and notice that the reference angle changes. So do all the F's first, then do all the D's. All right. So I'll pause this here. Here we go. Well, I should actually see. Hold on. Let's see how you did. So you got to be careful because it's kind of messy, right? When it's both angles, when we switch around. So for angle F, if you're here, and this is O, opposite, hypotenuse, and this is adjacent, okay? So then cosine of F, it's ka, right? Let me just see if I can, there we go. Cosine adjacent hypotenuse, that's what it calls for. So it's 27 over 45. Sine is, oh, wait. Yeah, I got it. Sine, right, is O over H. So it's 36 over 45. Tan is TOA, right? So it's opposite and adjacent in that order, 36, 27. If you flip this, right, 27 over 36, it's going to be wrong, okay? Watch this now. For this row here, it's D. So we need to position ourselves here. So all of a sudden, we scratch that, this is now the opposite. This is still the hypotenuse no matter what. And this is the adjacent. So you kind of change the name now. And what's going to happen is, watch this, like cosine of D is adjacent over hypotenuse. And sine is opposite over hypotenuse. Notice how they flipped, right? Sine of F, cosine of D, right? They switched. You switch now because you're situated at a different angle. And it's very important to understand that. And tan of D is opposite over adjacent. So notice how these are now flipped here, right? Because opposite and adjacent have changed, so it flip-flops here. So I hope this is a good review and it helps you to understand what's happening here. Having a good grasp of this will make you be more successful later on, because it's really having to think and stop and write, like reference angle, labeling, grabbing the two numbers in the right place, right? The right pair and in the right place, because if you don't put them in the right place, you're going to be off. Okay. So here we go. Let's do some solving here. So this is just trig ratios, putting down the numbers as they supposed to go. And so let's do some solve for the missing side. And what I'm going to do here is I'm going to give you maybe 3 questions. I'm going to stop, ask you to solve them, and then I'll solve them with you. Okay? So here you have your first triangle. (28 degrees), this opening here. This is 7.5 meters, and this is x. So this is our first question. We're going to call that question A. B we'll do here. And always, this is always my 90 here, assuming, right? This is 37. This is 23.4 meters. and this is x here, and last and there are your 3 questions. I'm going to pause this. So we use sine because O and H is the only one left. This is our reference angle. Make sure it goes on the video, right? The reference angle, because it's labeled opposite hypotenuse, are the only 2 sides that we care about. That means we need to use sine. We set it up in the right order. You put the 1 underneath. 7.5 times sine of 28 divided by 1. I just want to show you something, right? Before we continue. Sine of 28, it is a number. It is a decimal in this case. Most likely always going to be. And that's all you need to remember. You don't need to be scared of sine of or tan or anything attached to an angle. The calculator can give you an exact value for it. So you start on the side of where your variable is. In this case, since you're down, you're going to travel up multiplying, and you're going to divide by 1, which is not really necessary, but it just helps you to know which 2 numbers are being multiplied here. So x is going to be 7.5 times sine of 28 divided by 1. Don't do that on your calculator, it's just to show the work. So 7.5 times sine of 28. Wait, here, I'm going to show you here. 7.5 times sine 28, and depending on what calculator you have, you might have to do it slightly differently. Some of you need to first type in 28, like you basically need to go backwards. 28, then press sine, then you're going to get a value. Then you go times 7.5, and then you will get 3.52. And we are in meters, right? So you now found this side, which, by the way, is shorter than your hypotenuse, and that is a good thing because the hypotenuse is the longest of them all, right? So you got to watch out. You always got to question your answer. Could you now use Pythagorean theorem to solve for this side here? Yes, you could, because you have this side. You know what this is now. You could easily find that. We're not going to do that now, but I just want you to keep that in mind. Next, angle is here. That's my reference angle. Opposite, adjacent. This one is my hypotenuse. I don't know and I don't care about it. So O and A and O, it doesn't matter. Just go look it up. Which one has A and O at the same time? This one. So I'm going to use tan. So tan of 37 degrees is opposite comes first, so that's unknown. Adjacent comes next. Notice that the x can be denominator or numerator. It depends on the situation. 1 is there. That means that you need to multiply and divide like that. So x is equal to 23.4 times tan of 37 divided by 1. And that is 23 times times tan of 37. That's 17.63. And we are in meters still. So this is 17.63. Could you use the Pythagorean theorem now to find the hypotenuse? Absolutely, you could. All right. Last one, and I'm gonna call it. I'm just gonna mention one more thing, and then that'll be it for today. Okay. So your reference angle is there. Opposite would be here, but I don't care about it. This is the hypotenuse. This is the adjacent. If this is the opposite, then this must be the adjacent, right? So it's A and H. That stands for, I'm just going to scroll up a bit, A and H, cosine. So cosine of 23 degrees is equal to, A comes first, so 3.75, and H for hypotenuse comes next, which is our X. You put the 1 down here. You always start on the side where your unknown is. In this case, you have to travel down, so multiply there, divide up. Multiply and then divide. So see how that 1 helps you to know you're going to have to divide. So 3.75 times 1 divided by cosine of 23. And so you get 3.75 divided by cosine of 23. And that is 4.07 inches. And it makes sense. It should be longer than one of the legs. It's still, these two are still called legs when we consider the Pythagorean theorem. And the hypotenuse should be the longest side, which is the case so far. Okay. What I would say is, if you struggle with this still, look up, some of the worksheets that we've already done and try those, and see how that goes for you. So we're gonna start tomorrow doing more and more again. Watch for ACs. We have to find angles, which is a little different, and we have to also learn to do word problems, which is also that's the most challenging part of these. Okay. Other than that, I would say